Good morning, children.
Good morning, ma'am.
Good
Good
morning.
morning, ma'am.
Good morning, ma'am.
Good
Morning,
morning,
ma'am.
ma'am.
Morning.
Good morning, children. So I can
Good
see
morning, ma'am.
Gayatri. Good morning. Yeah, I can see Gayatri, Haridarshan, Harsha, Lakshana, Nuvid, Rahul, Sai Smriti, Shreya, Surya, and Yarni. Thanks for joining in, children. I've shared my screen. Is it visible?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Very nice.
Yes, ma'am.
Great.
Yes, miss.
Very good. Okay. So as I mentioned in the last class, in today's class, we are about to look into a bunch of very important questions, important concepts from exponents. Each question has a different approach. And in today's session, you will not be writing anything. We'll discuss, I think I have in this presentation 14 answers, 14 questions and answers. So we'll discuss all of them in today's session. I'll share the images with you on WhatsApp. You can complete them in your classwork later. Is that fine?
Yes,
Okay, ma'am.
Yes, ma'am.
Yeah, yeah,
Yes, ma'am.
Yes, ma'am.
yeah. So please, as always, feel free to ask your doubts once we finish, discussing an answer. Make sure you've understood them well, understood it well. You don't have any questions before we go to the next one. All right. Yeah, I think Yarni's mic is enabled. Kindly disable your mic, Yarni. All right. So this is the first question. We have an equation given to us. So 9 to the power n into 3 square into 3 to the power n minus 27 to the power n divided by 3 to the power 3m into 2 cubed is equal to 1 by 27. So this equation is given to us. This equation is true. This is given to us. So given this, we'll have to prove that m minus n is equal to 1. Do not read the answer ahead. Don't see the answer ahead. We'll go, see the step which I am explaining. Don't go ahead. That will confuse you. So given this equation, we'll have to prove that m minus n is equal to 1. So this is a simple one. We know that 9 can be expressed as 3 square. And this power n, you can see it here. 3 square as it is. 3 to the power n as it is, because that's already in the simplest form. Nothing can be done with that further. Then now 27 can be written as 3 cubed and this power n here divided by, again, these are very simple. Nothing can be done with them further. So write them as it is equal to 1 by 27. You can also write 27 at this point as 3 cubed. That's also fine. You can write 27 as 3 cubed here. I have written it somewhere here. You can also write it here. So basically in this step, we have written the composite numbers using their prime factors. So 9 is composite, so we write that as 3 square. 27 is composite, so we write that as 3 cubed. So basically in this step, we've written the composite numbers using their prime factors. This is the given equation. And here we have written the composite numbers using their prime factors. Now we'll use a law of exponents. When bases are same and it's multiplication, we add the powers. Or if it's division, we subtract the powers. We'll do that. So before that, 2 into n, 2n. 3 square here as it is, 3 to the power n as it is, 3 into n, 3n. And the denominator as it is equal to 1 by 27. So in this step, we just multiply the powers. 2 into n, 2n, 3 into n, 3n. So now in the next step, applying the law of exponents, in this step, you can see bases are same and it's multiplication. So we add the powers. In these three terms, you can see that the bases are same and it's multiplication. So we add the powers. So we have 2n plus 2 plus n. 3 raised to the power 2n plus 2 plus n. minus 3 to the power 3n as it is, divided by, in the denominator, the bases are different. The powers are also different. So the denominator as it is. So in this step, the only changes, these three terms have the same base. And it's a product. It's multiplication. So we add the powers. Using the law of exponents, we add the powers. So write the base 3 and add the powers 2n plus 2 plus n. And the other terms as they are. Now the sum here, 2n plus n is 3n. So 3n plus 2. So here we find the sum 2n plus n is 3n, 3n plus 2. The other terms as they are. The remaining terms as they look is equal to 1 by 3 cubed. I told you 27 is 3 cubed. You can change that at any point. You can do it here itself. Okay. All right. So now denominator cannot be simplified further because it's a product, but the bases are different and the powers are also different. So you cannot use any law of exponents here for the denominator. In the numerator also, we have simplified. So now what after this? So whenever, when we work with exponents and the connecting sign is a plus or a minus, you will have to take out the common factor. See, if the connecting sign is multiplication or division and the bases are same, you have a rule. You add the powers or subtract the powers accordingly. But when the connecting sign is a plus or a minus, you see that the bases are same. The bases are same, like here 3, 3. Bases are same. But the connecting sign is minus. It's subtraction. You cannot say bases are same and it's subtraction, so I subtract the powers. No, that's not the rule, right? So when the connecting sign is a plus or a minus, you'll have to take out the common factor. That's the rule. So here the bases are same, but the operation is subtraction. So you have to take out the common factor. So now what is common? We have two terms. Now what's common between these two terms? To understand that, we'll split this. See, this we'll not split this further because this one, even if you have to write it, you can only write it as 3 to the power 3, the whole power n. Now this can be written as 3 to the power 3n into 3 to the power 2. And when you write this as 3 to the power 3n into 3 to the power 2, you can see that 3 to the power 3n is common between the two terms. I'll repeat this part. We're talking about this one, how this can be, written in a different way. See here, 3 to the power 3n plus 2. So the earlier step, before this, it could have been 3 to the power 3n into 3 to the power 2. Because when bases are same and it's multiplication, please check your mic. Always put it on mute. I think it's Hari Darshan this time.
Ma'am,
disable your mic. No. You don't have to excuse yourself. It happens. Just disable your mic. Yeah. Yeah. So, yeah, the earlier step, 3 to the power 3n into 3 to the power 2. Why do we write it like that? Because bases are same, 3, 3, and it's multiplication. So what would we do? We add the power. So 3 to the power 3n plus 2. So this expression 3 to the power 3n plus 2, we are writing the earlier step. Before we use the law of exponents, it should have been like 3 to the power 3n into 3 to the power 2. See, the bases are same, 3, 3. It's multiplication. So what will you do? You'll add the powers, 3n plus 2, and that's what we have here. So we're writing that earlier step. So we write this term as 3 to the power 3n into 3 to the power 2. Into because it's plus 2 here. It's plus 2. So it's multiplication. Only then you add the powers. See, if it was minus 2, now your question will be, what if it was 3n minus 2? Supposing, okay? What if it was 3n minus 2? Then you'll have to write 3 to the power 3n into 3 to the power minus 2. Supposing this power was 3 to the power 3n minus 2, then you have to write it as 3 to the power 3n into 3 to the power minus 2. So when you use a rule, Bases are same, multiplication, add the powers. So 3n plus minus 2. So 3n minus 2. All right, so that's the only change in this step. That's the only change in this step. This is written as 3 to the power 3n into 3 squared. The other terms as they are. The other terms as they are. Now in the numerator, 3 to the power 3n is common. So this is one term. This is one term. And from this is common. So write this in the bracket, 3 square in the bracket. And this connecting sign minus. Now this is the second term. But this is common. See here, this is taken out common here. So there's nothing there, meaning 1, not 0, 1, 1. So multiply this into this will give you the first term, and this into this will give you the second term. This into this. 3 to the power 3n into 3 square. You can see it here. That's the first term. Minus 3 to the power 3n into 1. 3 to the power 3n. See, you can even write it as into 1 here. 3 to the power 3n into 1. Into 1. So this is common outside. So in the bracket, you will have 3 square minus 1. 3 square minus 1 in the bracket. And the denominator as it is, I've written 2 cubed as 8. See, these changes, 27 as 3 cubed, 2 cubed as 8. You can make it at any point. It's not that you have to do it here. You can do it at any point. But why have I done here? Because now we realize that the numerator here, is 3 squared 9, 9 minus 1, 8. So you can cancel 8 and 8. So, we just wait till here. We'll just see if because we want to have expressions in the exponential form, right? So we retain it in the exponential form and nothing's happened so far. But here we realize that 3 squared is 9, 9 minus 1 is 8. So you can cancel 8 and 2 cubed, right? So we write 2 cubed as 8. And you can see in the next step, they get cancelled. See, when you practice, you follow what your mind says. Now you've understood the procedure. You follow what your mind says. You shouldn't be very strict, like, writing 27 as 3 cubed at this point only and writing 2 cubed as 8 at this point only. See, if you felt you should write 2 cubed as 8 here, do it. Only then you will know the difference. So everybody, when we work, when we understand and we work with, we have some, you have some ideas in your mind and you execute your ideas. So you execute your ideas. So I've written 2 cubed as 8 and here 8 and 8 gets cancelled because 3 squared is 9, 9 minus 1, 8, 8 gets cancelled. Now we are left with 3 to the power 3n divided by 3 to the power 3m. So bases are same, division, subtract the powers. 3 to the power 3n minus 3m. Bases are same, it's division, so subtract the powers. 3n minus 3m is equal to 1 by 3 cubed. Can be written as the equivalent of that, 1 by 3 cubed. See, there's nothing but 1 by 3 the whole cube. It's the same. 1 by 3 cubed is nothing but 1 by 3 the whole cubed, because 1 cubed is 1. Now, how do you write the equivalent of this? Take the reciprocal of the base. The reciprocal of the base 1 by 3 is 3 by 1 or 3. The reciprocal of the base 1 by 3 is 3 by 1 or 3. Reciprocal of the base negative of the power. So plus 3 minus 3. When you do both the changes, you are writing the equivalent of the given expression. We have this, we have this. We make both the changes. Write the reciprocal of the base. Write the negative of the power. Here we have the equivalent of this one. The equivalent of this is this. So in the next step, you see 3 to the power minus 3. 3 to the power minus 3. Now again, using this other rule of exponents, when bases are same on both the sides, you can equate the powers. on either sides, on the left hand side and the right hand side, when bases are same. See, there's only one term on the left hand side. There's only one term on the right hand side. Only at this stage you can use this rule. There's only one expression on the left hand side and only one expression on the right hand side. At this stage, you can use this rule. When bases are same on either sides, that is on the LHS and RHS, equate the powers. Equate the powers. So it's like they get cancelled. Don't cancel, but like that. Like the bases get cancelled on both the sides. So we have 3n minus 3m is equal to minus 3. So when you divide by 3 throughout, or you can even, I can just include a step for you. You can take out 3 common here. 3 common here. So n minus m is equal to minus 3. Then this 3 comes for division, right? This 3 would come for division here. So n minus m is equal to minus 1. Changing the signs throughout. Changing the signs throughout. Minus m, write it as plus n. Plus n, write it as minus n. And minus 1 as plus 1. Changing the signs throughout. So we proved that m minus n is equal to 1. See, now you'll ask me now, how did you write without taking common from this step? How did you come here? See, so you divide by 3 throughout. Dividing by 3 throughout. Divide this by 3. So 3 and 3 will get cancelled. So we have n. Divide this by 3. So 3 and 3 cancels. We have m minus n. Divide this by 3. 3 and 3 cancel. So minus 1. So dividing by 3 throughout. You must divide by that non-zero value on both the LHS and the RHS. So dividing by 3 throughout, we get this step. And here in this step, changing the signs throughout. Change the signs throughout, meaning in the LHS and RHS. So plus n is minus n. Minus m plus m. Minus 1 plus 1. So like this, we proved that m minus n is equal to 1. Any questions, children?
No, ma'am.
No, ma'am.
Very nice. Very good. See the next one. So here we'll have to show that the value of this expression is equal to 1. Show that the value of this expression is 1. Here there's an equation. In this question, there's an equation. So we work with that equation, and using this equation, we prove that m minus n is equal to 1. Here, this one is not an equation. You will have to see, this one looks like an equation because it's equal to 1. But this is not given to be true. You'll have to show that. You'll have to prove it's true. Show that the value of this expression is equal to 1. So you'll have to work only with the expression. Show that this one is equal to 1. So take up only the left hand side. Only the left hand side. Now, this one, see, so we have a specific approach here. You will have to remember that. Now, what do you see common here? A, right? See here in the powers, B, A, C, A. So A is common. Here, A, B, C, B. So B is common. B, C, A, C. C is common. C is common, meaning C is repeated, I mean. Not the literal common. So like it's repeated. A 2 times. Here B 2 times. C 2 times. So here A is repeated, right? So you multiply the numerator and denominator by x to the power A. X to the power A. Now here what's repeated? B is repeated. So multiply this one. Multiply the numerator and denominator by x to the power B. And here C is repeated. Multiply the numerator and denominator by x to the power C. So it's like, see here, very simple. See here, there's a 1 here, right? That 1 is there. So 1 into multiply the numerator with x to the power A. This is the denominator, right? This is the denominator. Multiply that also with x to the power A. So you can see the denominator here. It's multiplied with x to the power A. So when you multiply the numerator and the denominator with the same value, you're not changing the value of that expression because See here, x to the power a, x to the power a cancels. So it's like 1. So like multiplying by 1. Don't we write equivalent fractions when we have 3 by 4? So we multiply, say, by 3, multiply and divide by 3, and we say 9 by 12. So 9 by 12 and 3 by 4, they're equivalent fractions. They have the same value. They look different. They look different, but the value-wise, they're the same. 3 by 4 is the same as 9 by 12. In the same way, this is an expression like a fraction. When you multiply the numerator and the denominator by the same thing, you're writing its equivalent. So you're not changing the value of that expression. You've just written its equivalent, right? So you multiply the numerator and denominator by x to the power a. Here, multiply the numerator and denominator with x to the power b. Here with x to the power c. And I told you how to remember that. Whatever is repeated. A repeated, multiply and divide by x to the power a. B is repeated, x to the power b. C is repeated, x to the power c. You can remember like that. So there is 1 here in the numerator, multiply by x to the power a. And this is the denominator, multiply that with x to the power a. So you can see the same thing everywhere. So 1 into x to the power b. This is a denominator into x to the power b. 1 into x to the power c. This is a denominator into x to the power c. That's the first step. Now, the numerator is simple. The numerator is everywhere. In the denominator, x to the power a into 1 is x to the power a. X to the power a into this one. So when you'll have to multiply these two, bases are same and it's multiplication. So add the powers. So you can see b minus a plus a. B minus a plus a. This into this, you can see it here. This into this. Add the powers. So b minus a plus a. This into this. Bases are same, multiplication, add the powers. C minus a plus a. Powers. C minus a plus a. Same thing here. X to the power b. This into this. X to the power a minus b plus b. And this into this. X to the power c minus b plus b. Same thing. X to the power c into 1. X to the power c into this term. So it will be x to the power b minus c plus c. Similarly, x to the power a minus c plus c. Bases are same, multiplication, add the powers. So then you see minus a plus a cancels. Minus a plus a, minus b plus b, minus b plus b, minus c plus c, minus c plus c. 0, no? So you cancel them. And this is what we are left with. After cancelling, we are left with this. You can see x to the power b, x to the power c. See, minus a plus a cancels. So we have only x to the power b there. All right, so in this step, we've just written what is left out of this step. Now LCM. In the next step, LCM. See, like if you have a by a plus b plus c plus b by a plus b plus c plus c by a plus b plus c. Okay. So what's the common denominator? A plus b plus c is the common denominator. So what will be the numerator? A plus b plus c. Then what happens? Cancels and the value is 1. We have a similar situation here. You can see the denominators are the same everywhere. It shows that the terms are in a different order. Okay, so you can see x to the power a, x to the power b, x to the power c. Right? So we have 3 expressions connected by the plus sign. 1, 2, 3 expressions. And on all these 3, the denominator is the same. So that becomes the common denominator. X to the power a plus x to the power b plus x to the power c is a common denominator. So as I told you with this example, see when we have A by A plus B by A plus B. So the LCM is A plus B. So in the numerator, we have A plus B. This A plus B. So in the same way here, x to the power A plus x to the power B plus x to the power C. Cancels, and that's 1. So you just have to start this answer by multiplying this expression, multiplying the numerator and denominator of this expression with x to the power A, multiplying the numerator and denominator of this expression with x to the power B, multiplying the numerator and denominator of this expression by x to the power C. That's it. If you do this, that's it. When you start right, this step will take you to the next one, and that to the next one, and that finally to the correct answer. And you remember like this, because A is common, we multiply and divide with x to the power A. B is common, C is common. So you can remember like that. Any questions, children?
No, ma'am.
No, ma'am.
Great. Next one. Okay, so here we are given that ABC is equal to 1. These are standard questions. Okay, we are given that ABC is equal to 1. So, from this you can write A is equal to 1 by BC. Or you can write B is equal to what? What is B equal to? Fast. You cannot take this long. If A is 1 by BC, what is B? 1 by?
1 by CA.
CA or AC. Yeah, what is C?
1 by AB.
1 by AB.
1 by
Very good.
AB.
Yeah, what is 1 by A? If A is 1 by BC, what is 1 by A?
BC.
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 Take reciprocals on both the sides. Take reciprocals on both the sides. If B is 1 by AC, what is 1 by B?
AC.
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 Very good. Taking reciprocals on both the sides. If C is 1 by AB, what is 1 by C?
AB.
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 Very good. Very good. So given ABC is equal to 1, we can interpret so many things. So you can say A is equal to 1 by BC, or 1 by A is equal to BC. You can say this. Or you can say B is equal to 1 by AC. So 1 by B is equal to AC. Or you can say C is equal to 1 by AB. Or 1 by C is equal to AB. So you have to use any one of these three. You'll have to use any one of these three to work this answer. Let me see what I have used. Okay. So I've used the C one. This one I've used. So I'll explain using this. You can do. See, I'll explain it and then you can relate what I meant. You can use this or this also. So now this part will not be clear because you really don't understand what I mean. We'll see the solution and then come back to this. So I have used these as I have used these results from what is given. ABC is equal to 1. I have used these results to work the answer. That is, I have eliminated C and 1 by C. In this expression, if I have C, I'm going to write it as 1 by AB. And if I have 1 by C, I'm going to write it as AB. So in the expression given in the question, we have three variables, A, B, and C. A, B, and C. So you choose to eliminate one of it. If you don't want A, see here in the given question, in the denominator, you can see A, B, C, C, A. All right. So you don't want all the three. You don't want A, B, and C. You're given that ABC is equal to 1. So if you don't want A, so wherever there is A, write 1 by BC. Where there is 1 by A, write BC. Or if you don't want B, If you don't want B, where there is B, you write 1 by AC. Where there is 1 by B, you write AC. If you don't want C, where there is C, you write 1 by AB. Where there is 1 by C, write AB. So like this, see, you have 3 unknowns. You're just eliminating one of it and making it only 2, like A and B only. Now let's see the answer. So we know that B to the power. So again here, this looks like an equation, but this is not given to be true. You have to prove that this one is equal to 1. So you'll have to work only with this expression. You'll have to work this expression and show that the value of this expression is equal to 1. Yeah. So this is the left hand side, this expression, right? This one. So the first step, B to the power minus 1 is 1 by B. C to the power minus 1 is 1 by C. A to the power minus 1 is 1 by A. That's the first step. Nothing else. No other changes made. Okay, we just write these as 1 by B, 1 by C, and 1 by A. Now, before you continue working, you should have decided what you don't want. So I decided I don't want C. So if it is A and B, I'm going to continue. If it is C, I'm going to replace. If it is C or 1 by C, I'm going to replace. If I have A and B, I'm going to continue with the next step. But if I have C or 1 by C, I'm going to replace them accordingly. As we understood, if ABC is 1, C is equal to 1 by AB. C is equal to 1 by AB. Let me tell you in the order I have written here. See, from this I've written 1 by C is equal to AB. Let me tell you how I wrote that. If ABC is 1, bring the C for division. Bring the C for division. So we have 1 by C is equal to AB. That's why I've written that first. So anyways, I'll show that again. See, ABC is equal to 1. Now I have written 1 by C is equal to AB, right? First. So how did I write that? So I brought the C for division. The C comes to the other side for division. So 1 by C is equal to AB. Now taking reciprocals on both the sides, 1 by C, the reciprocal of this is C, and the reciprocal of AB is 1 by AB. So C is equal to 1 by AB. Or both you can get from this itself, see. So from this, what is 1 by C? The C comes here, no? So 1 by C is AB, okay. And from the same thing, ABC is 1. From the same thing, what is C? What is C? 1 by AB. So you can understand it in different ways. So like when you look at this expression, you should decide what you don't want. So I don't want C. So you can see 1 by C. So wherever there is 1 by C or C, we replace accordingly. So here you can see 1 by C, no? So what is 1 by C? AB. So see here, this as it is, 1 by C is replaced with AB. And here C is replaced with 1 by AB. 1 by AB. That's all. Just do this and LCM and other things will bring you to 1. Without any effort, you will get the answer. But you should remember this. So again, this is a standard question. So you need to remember how to begin, how to start the solution. That is very important. It's not about working this 10 times. There's no time also for that. So when you look at this question, what is the trick? What is that trick which should be applied so that I get the answer in fewer steps? So this you should remember like theory. So this is a trick. So ABC is 1. There are 3 unknowns. So since I have this equation ABC is equal to 1, I'll not go ahead with A, B, and C. I'll eliminate one of the variables, either A or B or C. So here in this solution, we have eliminated C. So where there is C and 1 by C, we have used 1 by AB and AB. That's all. That's the only thing we have done here. So I'll come from here. This is the question which you see here. B to the power minus 1, C to the power minus 1, A to the power minus 1 is written as 1 by B, 1 by C, and 1 by A. That's the first step. And here we have taken the denominator, common denominator B, LCM B, because there's only A and B. There's no replacing further. But here 1 by C, is here. See, we have not taken the LCM here. That's what I'm trying to say. Don't take LCM C here because we don't want 1 by C. So what's 1 by C? AB. 1 by C is AB. And here also don't take LCM A. No, because we don't want C. No, what is C? 1 by AB. So C is 1 by AB. So here we have taken the common denominator, but here and here we have not, because we first want to replace. We first want to get rid of, or we want to eliminate 1 by C and C. So we replace with AB and 1 by AB. Now here we have taken the common denominator B. So we have B, that you should know, children, 1 plus A plus 1 by B. When you take the common denominator, so it's like you'll have to multiply B, right, into B, into B. Here it is into 1, into 1. This is right clearly. See, we have 1 plus A plus 1 by B. 1 by B. What's the LCM B? But what do we have here? 1. For the common denominator is B, but it's 1. So into B. So into B. Into B. Into B. Here it's B. So into 1. Into 1. So B plus AB plus 1 by B. That's what you see here. B plus AB plus B. Sorry. B plus AB plus 1 by B. This one we've been learning since, I think, standard 6. So there we take LCM where only numbers are involved. Here variables are involved. That's the only difference. Concept is the same. For how do you work with numbers? Same thing with expressions or variables. Okay. So LCM. Here, this one, there's nothing to do. And here for this, in the next step, LCM. AB is the LCM. 1 plus 1 by AB plus 1 by A. So AB is the common denominator. So here we have 1. Right? But this is the common denominator. So into AB, into AB. Into 1, into 1. Into B, into B. So we have AB plus 1 plus B. AB plus 1 plus B by AB. Okay. So you know that this B will go up to the numerator. And here this AB will go up to the numerator. This B will go up to the numerator. So 1 into B is B. And this AB will go up to the numerator. 1 into AB is AB. So actually, when you work this answer, no, things are not happening evenly. Like in one step, you've already taken the LCM for one expression, while not for the other. So things are not happening at the same time. So don't get confused. Here we've already taken the LCM. So in the next step, B goes to the numerator here. Whereas for this one, we are taking the LCM only in this step. So this AB goes to the numerator here. So same things are not happening in the same step. So overall, the idea here is you don't want C. So you're replacing C with 1 by AB. Or if you have 1 by C, you're replacing that with AB. That's all. Do that and take the common denominator for, the denominator. For this denominator, common denominator. This denominator, common, not here. This is already fine. So for this denominator, common denominator, LCM. That's it. Now, what do you see? You see BAB1, BAB1, BAB1. Same thing. So that's the LCM. So B1AB cancels 1. Right, children?
Yes, ma'am.
So you please try with the others also. You can try with replacing A and 1 by A, B and 1 by B also. You will get the solution. Very nice. Next one. I think this you can help yourself. There's no big funda in this. Nothing much in this, children. You can help yourself. It's just taking LCM everywhere. Nothing else actually. So a to the power minus 1 is 1 by a, 1 by a. This is 1 by a plus 1 by b. 1 by a minus 1 by b. Yeah, so this is actually simple. You can help yourself. This one also you can help yourself because you just have to find the, okay, let me read the question for you. If ABC, so I'll show you the question here. Yeah. So if ABC if ABC are distinct positive prime integers, distinct meaning different, positive prime integers. Distinct meaning different. They're not the same, like A, B, C all have different values. If A, B, C are distinct positive prime integers such that A square B cubed C to the power 4 is equal to 49,392, find the values of A, B, and C. Simple question. So just have to find the prime factorization. Work the prime factorization of the given number. Now, this is given to you. A square B cubed C to the power 4 is equal to 49,392 is given to you. Now, what is this? What is this? This is 2 to the power 4, 3 to the power 2, 7 to the power 3. Were written correctly? 1 second. 2 to the power 4, 3 to the power 2, yeah, 7 to the power 3, yes. Now, in the next step, I've just written it matching the powers here. Here, first the power is 2, then 3, then 4, no? So in the next step, I've just written the prime factorization in this order, power 2, power 3, power 4. So I've written this power 2 first, 3 square, into, then power 3, 7 cubed, then power 4, 2 to the power 4. I've just written it in this order, matching this one, power 2, power 3, power 4. So power 2, 3 squared, power 3, 7 cubed, power 4, 2 to the power 4. Now comparing both the sides. Comparing both the sides, a square is equal to 3 square. A square is equal to 3 square. So a is equal to 3. B cubed is equal to 7 cubed. So b is equal to 7. C to the power 4 is equal to 2 to the power 4. So c is equal to 2. The rule is when the powers are same on both the sides, you can equate the bases. On either sides, when the powers are the same, you can equate the bases. So using this rule of exponents, we find the values of A, B, and C. See, I always excuse myself in this aspect. This all typing. Okay, so I might see while typing 6194, maybe I've written 6174. So if there can be no mistake with the concept, but some typo error, you'll have to correct it. And let me know also so that I can change it in the presentation here. So I'm not saying any part of this is wrong. I'm just telling you. So somewhere if you find you're getting a different number, but I have shown a different number, don't get stuck there. So maybe while typing, there's a mistake. So I might have to change, what it looks like in my presentation. So just let me know. That's all. Yeah. So here we have an equation. We are given 9 to the power x plus 2 is equal to 720 plus 9 to the power x. This is given. This is true. You don't have to show that this one is equal to this. If this is equal to this, so this is true. This is given to you. Then you should find the value of 4x, the whole power 1 by x. So 9 to the power x plus 2 is equal to 720 plus 9 to the power x. Now this one can be written as 9 to the power x into 9 to the power 2. Bring all the terms to one side. So minus 9 to the power x minus 720 is equal to 0. Bringing all the terms to one side. See, now if you're like, how do I know that I should bring all the terms to one side? Okay, if you're not sure about that, you can even bring just this one too. You can just bring only 9 to the power. You can bring only this 9 to the power x. Why? Because we have 9 to the power x on the LHS, right? So you might think of taking the common factor. So there's nothing like you should get 720 to the other side. You should not get. Anything is fine. But 9 to the power x should be taken to the other side. 9 to the power x should be taken to the left-hand side. So again, 9 to the power x plus 2 is equal to 720 plus 9 to the power x. We write 9 to the power x plus 2 as 9 to the power x into 9 to the power 2. And since on the right hand side we have 9 to the power x, we transpose. So it comes here as minus 9 to the power x. You may or may not take 720 to the other side. That's fine. Anything is fine. Now here 9 to the power x is common. So we have 9 square minus what? 9 square minus fast.
1.
1. 9 square minus 1. Because it's like into 1 here. 9 to the power x is common. So in the bracket, you should write 9 square minus 1 is equal to 720. Is equal to 720. So 9 to the power x into 9 square is 81. 81 minus 1 is 80 is equal to 720. So 9 to the power x is equal to 720 divided by 80. 0 and 0 gets cancelled. 8 ones are 8, 9s are 72. 9 to the power x is equal to 9. 9 to the power x is equal to 9 to the power 1. X is equal to 1. Now you need to find 4 into 1, the whole power 1 by 1. So what is it? 4. Right?
Yes, ma'am.
Yeah. All right. Yeah, class, use the emoji. Raise your hand. Are you there? Hari, Gayatri? Yeah. Sai Smriti, Nuved Wahid, Surya, Shriya, Rakshana, Harsha, Yarni, Hari Darshan and Rahul. Are you there? Hari Darshan? Rahul?
Ma'am,
Yeah.
he's in restroom, ma'am. 2 minutes, ma'am.
Oh, sorry. Okay. All right.
Okay, ma'am.
Okay. So exactly what we discussed is in this slide. Okay, next one. Okay, I think I'll give all of you a break for 5 minutes. I'll just get back in 5 minutes, children. I'll get back exactly in 5 minutes. Please stay in the meeting.
Ma'am, what did you say now?
Yeah, what's that?
What did you say now, ma'am?
No, I said we'll take a break for 5 minutes. I'll get back at the end of 5 minutes.
Oh, okay, ma'am.
Yeah. Children, I'm back.
Ma'am.
Okay. All right. Okay. So in the first one here we have 2 to the power 2x plus 1. So now you know that it can be written as 2x into 2 to the power 2x into 2 to the power 1 is equal to 17 into 2 to the power x minus 2 cubed. 2 to the power 2x plus 1 can be written as 2 to the power 2x into 2 to the power 1. Base are same, multiplication. So add the powers, 2 to the power 2x plus 1, this one. So this can be split and written like this. So this is like 2 into 2 to the power 2x. Now see again, this will always be that should I bring everything to one side or only 2 to the power x? I told you, you can do anything. But this x, this 2 to the power x, that term you should bring it to the left hand side. That you should bring it to the left hand side. Okay. So minus 17 into 2 to the power x. Now this minus 2 cubed, you can have it on this side, or if you feel it's minus 2 cubed, so you can take it to the other side as plus 2 cubed. I'm saying that you will not know for sure what to do in every step, but certain things you will know for sure. Like you know that you have to transpose this, but with this you're not sure now. So you can have it on that side or take it to the other side. But this one has to be transposed. Why? Because you feel there is 2 to the power x here. Here also there's 2 to the power 2x, something in common. So you think something can happen when you have them together on the same side. So I'll come again. 2 to the power 2x into 2 to the power 1 is equal to 17 into 2 to the power x minus, you can also write 2 cubed as 8. See, okay. Now, 2 into 2 to the power 2x minus 17 into 2 to the power x plus 8 is equal to 0. So here I've taken all the terms to one side. Okay, all the terms to one side. 2 into 2 to the power 2x minus 17 transpose. So minus 17 into 2 to the power x minus 8 as plus 8 on the other side is equal to 0. Now this is 2 to the power 2x. So 2 to the power 2x can be written as 2 to the power x the whole squared. See, you don't want to write it as 2 square the whole power x. You don't want to write like this because you can also write it like this. 2 to the power 2x can be written in two ways. You can write it as 2 squared the whole power x, or you can write it as 2 to the power x the whole square. But you choose this one. Why? Because you have 2 to the power x here. So you want 2 to the power x. You don't want 2 to the power 2. I'll tell you that again. Since you have 2 to the power x here, you would like to write 2 to the power 2x as 2 to the power x the whole square. You prefer this one because you have 2 power x here. You can also write this as 2 to the power 2 the whole power x. But this is correct. But it will not help you in this situation. So you don't want to write it like this. You want to write it like this. So 2 into 2 to the power x the whole square, because we have 2 to the power x here. So 2 to the power x the whole square. So what is this? Multiply the powers, right? So x into 2, 2x. Minus 17 into 2 to the power x plus 8 is equal to 0. Now, common, if you can take out 2x common throughout, it's fine. But here this one does not have, 2 to the power x common. And one more thing you should realize is when you replace, say like this 2 to the power x, you must visualize that. Now just replace 2 to the power x with, some other variable like say y. Just read this, just visualize that 2y square minus 17y plus 8 is equal to 0. So this visualization you should do. So you can get a quadratic equation which can be solved by splitting the middle term. So this is what we are going to do. This is what we are going to do. What we're going to do is we're going to replace 2 to the power x with a different variable like y, z, b, whatever. Okay, so before you do that, you just visualize how will it look like. So 2, if you put this one as y, so y square minus 17, 2 to the power x is y, plus 8 is equal to 0. Yeah, so see, it's a quadratic equation in y. And this you can solve by splitting the middle term. And you'll get two values for y. But what is y? 2 to the power x. Okay, what is y? 2 to the power x. So like this, you can find the question is to solve the equations for x. So like this, you can find the values for values for x. Okay, so now see the answer. So I'll just take you beyond this. So see, this is the quadratic equation. Split the middle term. Find the two values for y. Y is equal to 8. Y is equal to 1 by 2. So y is equal to 8. Who's y? Y is 2 to the power x. We replaced 2 to the power x with y. So if y is 8, it means 2 to the power x is 8. So that means 2 to the power x is equal to 2 cubed because 8 is 2 cubed. Now bases are same. Equate the powers. X is equal to 3. X is equal to 3. So here we get y is equal to 1 by 2. Y means who's y? 2 to the power x. And how do you write 1 by 2? 2 to the power minus 1. So bases are same, equating the powers, we get x is equal to minus 1. So the values of x are 3 or minus 1. So you must, have the picture of this type of question in your mind. So when you look at a question like this in the exam, it should occur to you that, okay, this I can convert it to a quadratic equation and solve for the variable. So taking a picture of this question in your mind, the style, how the question looks like, 2 to the power 2x plus 1. Just read it once or twice. Focus on the question. Read the question once or twice. 2 to the power with involvement. Only your mind, what you say, your mind must be receiving that. 2 to the power 2x plus 1 is equal to 7 into 2 to the power x minus 2 cubed. So just look at the question, the picture, the brain will read in the picture. So something like this, this can be converted to a quadratic equation. You can solve it very conveniently by splitting the middle term, find the values of y, and hence find the values for x. We'll see it again. So see here, quickly we'll do it. 2 to the power 2x into 2 to the power 1 is equal to 17 into 2 to the power x minus 8. Bringing all the terms to one side, 2 into 2 to the power 2x minus 17 into 2 to the power x minus 8 is equal to 0. 2 into 2 to the power x the whole square minus 17 into 2 to the power x minus 8 is equal to 0. Let 2 to the power x be equal to y. Now replacing 2, this is y. So y square minus 17, this is y minus 8 is equal to 0. So this is the quadratic equation. Is that fine, children?
Yes, ma'am.
Okay. Any questions?
No, ma'am.
No, ma'am.
No questions, ma'am.
No, ma'am.
All it
No,
should. Okay. So this is
No,
similar one.
ma'am.
Kumar. Very nice. Okay. Similar question. 5 to the power 2x into 5 to the power 1 is equal to 6 into 5 to the power x minus 1. So 5 to the power 1 is 5, okay, into 5 to the power x the whole square minus 6 into 5 to the power x plus 1 is equal to 0. So 5, this is say y, so y square minus 6y plus 1 is equal to 0. Quadratic equation, split the middle term, find the values for y and hence find the values for x. So similar to the first one. So what are the values we get for y? 1 by 5 and 1. And what is 1? 5 to the power 0. What's 1? 5 to the power 0. What's 1 by 5? 5 to the power minus 1. So 5 to the power x is equal to, because we've assumed 5 to the power x to be y. Let 5 to the power x be equal to y. So we have y 1 by 5, y 1. So if y is 1 by 5, that means 5 to the power x is equal to 1 by 5. And what is 1 by 5? 5 to the power minus 1. Here 5 to the power x is equal to, what is 1? 5 to the power 0. Anything raised to the power 0 is 1. Remember, 1 should be written as 5 to the power 0. If the base is 2 here, you should write 2 to the power 0. If the base is 3 here, you should write 3 to the power 0. Here it is 5 to the power x, so 5 to the power 0. Okay. So on equating the powers, we have x is equal to minus 1 or x is equal to 0. To answer this question, you need to recall this identity. X minus y into x squared plus xy plus y squared is equal to x cubed minus y cubed. We have seen this identity earlier, same chapter, where we had to find the value of x cubed plus 1 by x cubed minus 1 by x cubed.
Yes, ma'am.
Yeah. So a set of identities have already been introduced to you. You can just go back, look into your notebook after the class. So this is the identity, x minus y into x squared plus xy plus y squared is equal to x cubed minus y cubed. Now, why are we talking about this identity? Because we have a part of it here. We have a part of it here, x squared plus xy plus y squared. Now, why is this alone? Why is it not along with this? So you're like, it's incomplete. This one is there, but why it's not along with this? Because if it were x minus y into x squared plus xy plus y squared, then you can use this identity and write it as x cubed minus y cubed. But you find only a part of it here. So what you do is you multiply the numerator and the denominator with whatever you want. You want something, right? What do you want? You want this x minus y also to be there. You want this one to be multiplied with x minus y. Do it. Do it. Multiply the numerator and denominator with x minus y. Multiply the numerator and denominator with x minus y. This one, not this part. This is x plus y minus, here we are talking about this one here. Okay, so here you multiply the numerator and denominator with x minus y. This one also multiplied with x minus y. So then what will happen? What will happen? We will have x plus y minus 1 into x minus y is x minus y divided by x minus y into x squared plus xy plus y squared is x cubed minus y cubed. Identity. Now this looks somewhat better. Now, what's the value of x cubed? If x is equal to cube root of 28, if x is cube root of 28, cube it on both the sides. Cube it on both the sides. So x cubed is equal to 28. What is cube root of 28? The whole cubed, 28. Because it will be cube root of 28 means 28 to the power 1 by 3. Cube root of 28 in the exponential form is 28 to the power 1 by 3 into 3. So 3 cancels, so it's 28. X cubed is equal to 28. Similarly, cube root of 27 is 3. You can take as 3. So y cubed is what? 3 cubed 27. See, y is equal to cube root of 27. Cube root of 27 is 3. So y cubed will be 3 cubed 27. So in the next step, x plus y minus x minus y, you can put this in a bracket also if you want. If you want, because here we use a bracket. No, you can put a bracket here if you want. X cubed is 28 minus y cubed is 27. So we have x plus y. Now this is 1, no? 28 minus 27 is 1. So denominator is gone. So in the numerator, you'll have minus x, minus into minus plus y. Minus x plus x cancels. Y and y is, meaning y plus y is 2y. 2y. And what's the value of y? 3. The value of y is 3 in the question. Y is 3. So 2 into 3, 6 is the answer. So the value of the expression is 6. So we have to find the value of this expression. So that's what you see here. X plus y as it is. You multiply the numerator and denominator with x minus y. That's the first step. Next step, this one you can see as it is, minus x minus y as it is. And this one by using the identity, it's x cubed minus y cubed. Now here we're going to substitute the values, right? So just show them. X is given to be cube root of 28. So when you cube on both the sides, x cubed will be 28. Cubing on both the sides. So here also y is equal to cube root of 27, which is 3. So y cubed will be 27. Now use those values. Be very careful here. There's a minus and there is x minus y after it. So put it in a bracket. After the minus sign, if it is after the minus sign, if there is more than one term, you must put them in a bracket. Because that minus sign will be applicable to all the terms. So it will be minus x plus y. Cancels. Y plus y is 2y. And 2 into 3 is because y is 3. So 2 into 3 is 6. That's about this answer. I just need 10 more minutes, children. I think I have 14 in this presentation, I told you, right? Of which the 11th one you can help yourself. I'll share the solutions. 11 you can help yourself. We'll see. Just give me 10 minutes. Let me see how much I can finish. So here also we use the identity. You can see that there are two brackets. Something plus something. And you can see 1 by 3, the whole square is 1 by 3, the whole square is 2 by 3, right? 1 by 3, the whole square. So multiply 1 by 3 into 2, 2 by 3. So this one is squared here. And you can see this one is also squared here. Because when you raise this to the power 2, you will get this. And this one, when you multiply these two, you'll get 1. Because x to the power 1 by 3 into x to the power minus 1 by 3. When you multiply, Add the powers. So x to the power 1 by 3 minus 1 by 3. X to the power 0, which is 1. So we see some connection between the terms in the second bracket and the terms in the first bracket. There is a connection between these three terms in the second bracket and the two terms in the first bracket. What is the connection? The connection is given these two, given these two terms in the first bracket, when we square this, we get this term. When we square this, we get this term. And when we multiply these two, we get 1. See, x to the power 1 by 3, when you square it, you will get x to the power 2 by 3. Similarly, x to the power minus 1 by 3, if you square it, you will get x to the power minus 2 by 3. So squaring this, you get this one. Squaring this, you get this one. Okay, and then how do we get 1? When you multiply these two. So x to the power 1 by 3 into x to the power minus 1 by 3. When you multiply, x to the power 1 by 3 minus 1 by 3. So x to the power 0, which is 1. So if you call x to the power 1 by 3 as A and x to the power minus 1 by 3 as B, the expression can be rewritten as x to the power 1 by 3 is A plus x to the power minus 1 by 3 is B. Okay. Then how do you get x to the power 2 by 3? When you square this one. So A square. When you square this one, you get x to the power minus 2 by 3. So it's a B square. And when you multiply these two, you get 1. So that is AB minus AB. You're just replacing with A and B so that the whole thing looks simpler. Just a minute. I'm not. Yeah. X to the power 1 by 3. When you square this, x to the power 1 by 3, the whole square, you get x to the power 2 by 3. X to the power minus 1 by 3. When you square it, you get x to the power minus 2 by 3. And when you multiply x to the power 1 by 3 and x to the power minus 1 by 3, you get x to the power 0, which is 1. So we replace all this with A and B. Now, if you call x to the power 1 by 3 as A, this is A plus this is B. Then in terms of A, what is this? A square. In terms of B, what is this? B square. And what is this? It's A into B minus AB. So this is nothing but A cubed, A cubed plus B cubed. A cubed plus B cubed. What's the identity? A cubed plus B cubed is equal to A plus B of A square minus AB plus B square. A cube plus B cube is equal to A plus B of A square minus AB plus B square. So that's what we have here. So this is A cubed plus B cubed. Right? But what is A? What's the value of A? Who's A? X to the power 1 by 3. Who's A? X to the power 1 by 3 into 3. Plus who's B? X to the power minus 1 by 3. Who did we call A? X to the power 1 by 3. So write that, and there's 3 already there into 3. Who did we call B? X to the power minus 1 by 3. Put it back. And then this 3 here into 3. So 3 cancels, 3 cancels. We have x to the power 1 plus x to the power minus 1. So that means x plus 1 by x. X is 3 plus 1 by 3. So 3 plus 1 by 3 is 10 by 3 or 3 1 by 3. That's about this answer. Okay. I think this question we have solved more than at least 3 times in the class. More than at least 3 times. So I'm not doing it again. Maybe same or similar. Last class also we had done a question like this. Okay. So this, I'm just leaving it to you. You can recall and complete this yourself. 11, as I mentioned earlier, it's mostly numerical. There's, I think, yeah. So there's this x everywhere, and you'll have to solve to find the value of x. So I'm sure with the help of the solution, they provided the solution. I'll be sharing this with you on WhatsApp. Very simple. So you can do this. Nice. Yeah. This finished 13 and 14. I think they're easier, meaning less time consuming. Yeah. I'll just finish 13. We will do the 12th one. I'll just check if all of you can stay back for a little more time because it's past breakfast time. So some of you might be waiting for me to wind up the session. So I'll just check with you and then do the 12th one. Otherwise, we have to do it later. Let me finish 13 and 14. Okay. Yeah, 13 and 14. Yeah. I had planned this for today's class. I just want to finish it, but I'm not in a hurry. You know, it's very important that all of us understand, all of us are in the right state of mind to listen to what, I'm trying to convey. So that's very important. Let's see this. So prove that XYZ is equal to 1 given certain things here. All right. Okay. So now you have to prove that XYZ is equal to 1. Now I've started with a to the power. I've started with a to the power XYZ. You can even write b to the power XYZ, c to the power XYZ. See, the thing is, you want to start like that, a to the power XYZ. Assuming that, you can just get this is equal to a to the power 1. And on equating, base are same, equating the powers, you get XYZ is equal to 1. You can start with a to the power XYZ or b to the power XYZ or c to the power XYZ. You can use anything instead of, you can use b and c instead of a. So I've started, so you have to get started like this. You have to write this by yourself. You'll ask me, where is a to the power XYZ? It's not there anywhere. No. You have to get started like that. You write a to the power XYZ. Now, what do I say? Write it in different ways, suiting what is given to us. Now see here, we are given that a to the power of x is b, right? So what you do, you write a to the power x in the bracket and put yz outside. You write you start with a to the power xyz. Now you write a to the power x in the bracket because you know that a to the power x is b. So you write a to the power x and write yz outside. Now replace. So this one comes down as it is. A to the power xyz is equal to, what is a to the power x? B. So b to the power yz. Now b to the power y is c. So what you do, this yz, right? B to the power y whole power z. Now what is b to the power y? It is c. It is c. So b to the power y is c. C to the power z. But what is c to the power z? It's a. It's a, which is a to the power 1. So on equating the powers, x, y, z is equal to 1. On equating the powers, x, y, z is equal to 1. You should try with b to the power x, y, z and c to the power x, y, z. I don't want to do it for you. Similar steps. Similar steps. So I started with a to the power x, y, z. And we write this as a to the power x, the whole power y, z. Why? Because a to the power x is b. So what is a to the power x? It's b. Now this is b. Now this is b. Now we have b to the power y. So a to the power x, y, z is equal to b to the power y, the whole power z. But what is b to the power y? It is c. So this becomes c. Now what is c to the power z? It's a. So a to the power x, y, z is equal to a. A meaning a to the power 1. So x, y, z is equal to 1. Yeah. Before I go this, we just recall. See here. If you have say like a to the power x, okay, we have x here, no? Okay. So a to the power x, if this is equal to k, then a is equal to k to the power 1 by x. Now, how do we get this? Raising both the sides to the power 1 by x. Raising both the sides. See, you can do anything, but do the same thing on both the sides. Whatever you do the same thing on both the sides. If you're raising the left-hand side to the power 1 by x, 1 second, children. Yeah, sorry, children. So raising both the sides to the power 1 by x. See, we have a to the power x is equal to b to the power y is equal to c to the power z. Okay, let me say, let the whole thing be equal to something like k. All these three are equal. All these three are equal is given. A to the power x is equal to b to the power y is equal to c to the power z is given. So let all this be equal to k. So now we have a to the power x is equal to k. Raise both the sides to the power 1 by x. Raise both the sides to the power 1 by x. So we have a is equal to k to the power 1 by x. Similarly, b to the power y is equal to k. Raise both the sides to the power 1 by y. Raise both the sides to the power 1 by y. Y gets cancelled and we have b is equal to k to the power 1 by y. We're getting the values meaning expressions for a, b. And now we're going to get for c. A is equal to k to the power 1 by x. B is equal to k to the power 1 by y. Everything we're getting in terms of k. Now c to the power z is equal to k. Raising both the sides to the power what?
1 by x.
No.
1 by, sorry, 1 by z.
1 by z. Raising both the sides to the power 1 by z. So z cancels. We have c is equal to k to the power 1 by z. So now what's the benefit of doing this step? We have a, b and c all in terms of k. All in terms of k we have. Now we are given another condition. B square is equal to AC. B square is equal to AC. What is B square? B is k to the power 1 by y. B square is equal to AC. What is A? K to the power 1 by x. into C, k to the power 1 by z. So working this, you will get the result. You will be able to prove that y is equal to 2xz by x plus z. So we got A is equal to k to the power 1 by x, B is equal to k to the power 1 by y, C is equal to k to the power 1 by z. Now we have all this we get from this condition given. Now we have another condition, B square is equal to AC, which we have not used. These we got from this one. Now we have this given to us. B square is equal to AC is given to you. So B square is equal to AC. B square means k to the power 1 by y square is equal to A into C. K to the power 1 by x into k to the power 1 by z. So k to the power 2 by y is equal to k to the power 1 by x plus 1 by z. Base are same on both the sides. So equating the powers, 2 by y is equal to 1 by x plus 1 by z. Common denominator, 2 by y is equal to xz is a common denominator. So you'll get z plus x in the numerator. Now cross multiply. 2xz is equal to y into x plus z. Cross multiply. 2xz is equal to 2xz is equal to y into x plus z. Z plus x, I just wrote it as x plus z. So y is equal to 2xz, y is equal to 2xz divided by x plus z. 2xz divided by x plus z. Good. So from this one, we have these, and then you'll have to use this equation, substitute. Base are same, equating the powers, you get the result. Okay, no, I think this one, so of the 14 questions, we have discussed everything except the 12th one. 11th one, I left it to you. You can do it by yourself. Now this will take some time, children, so I don't want anybody to find it inconvenient to continue. 12th one, yeah, this will take. So I'll share the images on WhatsApp. You try your best to understand. Can I just ask you all, I just want your honest reply. How many of you can stay back for another 10 minutes? Or if for those, if it's not convenient, if you can permit me that you will use the recording to understand this last part, I can go ahead and finish it. Like if for some of you it's not convenient to stay back for another 10 minutes, if you permit me, I'll go ahead, I'll complete it. You can make use of the recording for this 12th explanation. Can I do that?
Okay, ma'am.
Yes.
Yeah, if you have to leave or for some reason you're not able to stay back in the meeting, yeah, with your permission, I'm going ahead. Please make use of the recording. So those who want to leave at this point can leave the meeting.
Thank you, ma'am.
Yeah.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Okay, so Harsha, Rahul, and Lakshana can stay back, is it?
Yes, ma'am.
Okay, very nice. Thank you. Yeah. So we'll continue. 10 minutes, I'll just finish it. Yeah. Now this is the 12th one. So here you have two equations given to you. Solve the following equation for x and y. Equations. Solve the following equations for x and y. So this question, we have two equations. So you'll have to solve these two equations and find the values of x and y. You can see x here, y here, you can see x here, you can see y here. So solve the equations for x and y. So take up the first equation, take up this one. Now you can see 3, 9, 3. So write 9 as 3 squared. And here, base are same multiplication, add the powers. And next, on either sides, we have the same base. So equate the powers. So we have an equation, x is equal to 2 plus y. Now, whenever we have to solve two equations, you have the variables on one side and the constant on the other side. So we write x minus y is equal to 2. We have the variables on the left-hand side and the constant on the right-hand side. There is a standard way of writing it. When the equation has two unknowns, when an equation has two unknowns, here like x and y, we write the variables on one side, x and y on one side, and the constant on the other side. So this is the first equation we have in x and y. Now take the second equation given to you, this one. Okay. Now 8 is 2 cubed, 2 to the power y, and 4 is 2 squared, and this x. So here base are same, multiplication, add the powers, 2 to the power 3 plus y. Here multiply, 2 into x, 2x. Now on either sides, base are same on both the sides. So equate the powers. So 3 plus y is equal to 2x. 3 plus y is equal to 2x. Base are same, so ignore the bases. Equate the powers. 3 plus y is equal to 2x. Now have the variables on one side and the constant on the other side. So like if you bring this here, if you bring this plus y here to this side, it will become minus y, no? So 2x minus y is equal to 3. 2x, this plus y, if it comes here, so it's 2x minus y is equal to 3. That's what you see here. 2x minus y is equal to 3. Now this is the second equation. Now write the equations one below the other. This is solving by the elimination method. We are solving now here the two variables or the two unknowns are x and y. We are going to solve these two equations by the elimination method to find the values of x and y. Elimination method, as the name suggests, you will have to eliminate one of the two variables. You'll have to eliminate, get rid of one of the variables. Now that is possible here because this is minus y, minus y. But if it were minus y plus y, you could have cancelled it. Minus y plus y is 0. Minus y is minus 2y. So what you do, you change the signs throughout. In the second equation, change the signs throughout. See, it's not compulsory to change. Supposing this was already plus y, supposing, then you don't have to change the signs. Directly they'll get cancelled. Minus y plus y is 0. So changing the signs throughout in the second equation is not compulsory. It's situational. If the situation demands, you have to do it. To eliminate x or y, if you have to change the signs, do it. If it's not needed, don't do it. Here it is needed because minus y and see, x and 2x anyways cannot get cancelled. X and 2x, because if it, whether it is plus or minus, whether the signs are plus or minus, x and 2x will not be 0. It will be something other than 0. Irrespective of the sign, whether it is plus x or minus x, whether it is plus 2x or minus 2x, you cannot get 0 because the coefficients are different. If it's a plus 5x, it should be a minus 5x. The coefficient should be the same. This is 1 and 2 here. So anyways, you cannot get 0. But here, this is minus y, like 1 by 1 by. The coefficients are the same. So this one you can eliminate. We change the signs throughout. So here, this is plus 2x, right? So minus 2x. This is minus y, plus y. This is +3, so -3. So here, while typing, I cannot put it here. So I show the signs here. You can, do it like this. You can put it here itself, like this in brackets. Change the signs. +2x is -2x, -y is +y, +3 is -3. You can just write it like this in a bracket. That's what I've shown below here. Now what happens? -y plus y cancels 0. Because -y plus y is 0, no? So now like this, you've eliminated the variable y. Now x minus 2x. X, simplify the remaining. We're simplifying throughout actually. -y plus y is 0, so we cancel or we eliminate the variable y. Now x minus 2x. Take the new sign. Forget the old sign. X minus 2x is minus x. 2 minus 3 is -1. Minus and minus gets cancelled on both sides. X is equal to 1. Now we found the value of x. Solve for x and y. We found x. Now how do you find y? Now we have two equations, no? We have two equations. We have this one and we have this one. So put the value of x in this equation or this equation, any one of the two equations. X is equal to 1. Put this value in this one or this one. So I have put it in this equation, x minus y is equal to 2. So that means x means what? 1. 1 minus y is equal to 2. X minus y is equal to 2. This is the first equation, but x is 1. So 1 minus y is equal to 2. Work this and find the value of y. Y is equal to -1. So like this, we solve and find the values of x and y. So here we have two conditions given in the question. Two equations given in the question. So we take the first equation and we construct an equation in x and y. We have x and y on one side and the constant on the other side. We take the next equation and using this we get another equation in x and y. We have x and y on one side and put the constant on the other side. Then we write the two equations one below the other. We observe that the y variable can be eliminated. For that, the signs have to be opposite. Because the coefficients are already the same, 1y, 1y. So if it is plus 1y, minus 1y, it's 0. So we change the signs throughout. Minus, plus, minus. Minus 1y, plus 1y, 0. X minus 2x, minus x. 2 minus 3, minus 1. So like this, we find the value of x. And then we substitute in this equation, or you can put it in this also. You'll get the same answer. We find the value of y. That's about this one. Yeah, children, any questions here? If I'm not clear, please ask me. I'll repeat.
No, ma'am.
Okay. Okay. Okay, so here also we have two equations. You can see this one and this one. I have worked this in the first column. I've worked this in the second column. So using this, we get a linear equation in x and y. Using this one, we get another linear equation in x and y. And we solve the two equations. We get the value of y first. We substitute and get the value of x. So similar to the earlier one. Similar to the earlier one. Look at the question, how it is. Two equations we have. This is one equation. This is the other equation. So as I told you, using this equation, we get one equation in x and y. Have the x and y variables on one side and the constant on the other side. Using this equation, we get the second equation in x and y. So see, I have x and y on one side and the constant on the other side. Then we write the equations one below the other. We solve the two equations to find the values of x and y. Okay, so that's the outline of this answer. Now let's see it in detail. This is the equation given. So square root of 32. Okay, so this is in the radical form. Let's put it in the exponential form. So square root. Can you see the square root symbol? It's 1/2 here. The square root is written as 1 by 2. This is the radical form. Its exponential notation is 1 by 2 to the power 1 by 2. And 32 is 2 to the power 5. 32 is 2 to the power 5. Square root. The radical form is square like this. Its equivalent exponential form is to the power 1 by 2. Okay, so 2 to the power 5 to the power 1 by 2. And then there's already this x here. So to the power x divided by this one is equal to 1. Now here when you multiply, you get 5 into 1 by 2 is 5 by 2. And this x divided by this is equal to 1. So now bases are same. You can also write this directly as 5x by 2. You can write it directly as 5x by 2. Because 5 into, it's 5 into 1 by 2 into x. It's 5 into 1 by 2 into x. So it's 5x by 2. 5x by 2. That also is fine. So bases are same and it's division. So you'll have to subtract the powers. So 5x by 2, you can't see the minus. So that's the problem when it's exponents. There's a minus here. See, this is the power 5x by 2. This is the other one, y plus 1. And subtract the powers because it's division. See, I told you, you can write this as 5x by 2 straight away. 5x by 2, that's what you see here. This is y plus 1, you can see it here. And it's division, bases are same and it's division. So we subtract the powers. There's a minus here. It's very faintly visible, but there's a minus here. Is equal to 1. So when you open the bracket, minus y minus 1. And 1 is 2 to the power 0. So bases are same on both the sides. Equating the powers. 5x by 2 minus y minus 1 is equal to 0. Take the common denominator and cross multiply. After taking the LCM and cross multiplying, 0 into 2 0. Oh, sorry. Yeah, 0 into 2 is 0. And then this minus 2 comes to the other side as plus 2. 0 into 2 is 0. Then this minus 2 comes to the other side as plus 2. So we have 5x minus 2y is equal to 2. I told you, have x and y on one side and the constant on the other side. This 2 into 0 is 0. Then this minus 2 will come to the other side. No, that's plus 2. So we write 32 as 2 to the power 5. The square root is written as to the power 1 by 2. And this x here. And when you multiply the powers, you get 5x by 2. And here the power is y plus 1. It's division. The bases are same 2. So we subtract the powers. And on the other side, we have 1. But the base is 2. So we write 1 as 2 to the power 0. If the base is 3 here, write this as 3 to the power 0. If the base is 5 here, write it as 5 to the power 0. Then bases are same, equating the powers, taking the LCM, cross multiplying and all that, you get an equation. That equation, write it in this form. Have x and y on one side and the constant on the other side. Now take the second equation given to you. Write 16 and 8 in base 2. Write 16 and 8 in base 2. 16 is 2 to the power 4. 8 is 2 cubed. Already there's this power 4 minus x by 2, write that. And here 8 is 2 cubed. There's this power y, write it. Is equal to 0. Now you'll have to multiply the powers, right? When the base is raised to more than one power, multiply the powers. So 4 into 4 minus x by 2. So be careful here. Here, since there's a 0 here, I'm taking this to the other side so that I can equate the powers. Here there was a 1. There was a 1 and it was division here. So since it was a division here, we could subtract the powers. And this 1, we wrote it as 2 to the power 0. But here there's a 0 here. There's a 0. 0 is not 2 to the power 0. 1 is 2 to the power 0. 0 is 0. And here also, it's not multiplication or division. It's minus here. Here, no, it's not into. It's not multiplication or division. It's minus here. So what we do is we take this one to the other side. So when you take this to the other side, you can use a rule when bases are same, you can equate the powers. I'll come again. So this is the second equation given to us. Write 16 as 2 to the power 4, 8 as 2 cubed. There is this y here, and this power as it is. Now, when the base is raised to many powers, multiply the powers. So this into this is what you see here, and this into this, okay, you see it here, 3y. I've taken this to the other side. All right. Okay, so now 4 into 4 is 16. And when you multiply 4 into x by 2, 4 into x by 2, 2 ones are, 2 twos are. So 2x, you see it here, 2x. 4 into 4 is 16. 4 into x by 2 is 2x, you see here. And 3 into y is 3y. See again, this 3 into y, 3y, here itself you could have written. I told you, you can. So yeah, maybe even I'll change that. You can write this 3y here itself. Okay, so now base is same on both the sides. So equating the powers, 16 minus 2x is equal to 3y. And then minus 2x minus 3y is equal to minus 16. Changing the signs throughout. Minus 2x is plus 2x. Minus 3y as plus 3y. Minus 16 as plus 16. Changing the signs throughout. Changing the signs throughout, we get this equation. This is the second equation. Now, when you look at the two equations, so both the equations, we have written it in the standard form. We have x and y on one side and the constant on the other side. But when you look at the coefficients, 5x, 2x, the coefficients of x are 5 and 2. And when you check the coefficients of y, 2 and minus 2 and plus 3, they're not the same. So even if you change the signs throughout in the second equation, you cannot eliminate x or y, because eliminating x or y is possible only if they have the same coefficients but opposite signs. That's the condition. If you have to get rid of one of the two variables x or y, they must have the same coefficients and opposite signs. So if it is plus 3y, in the other equation, it should be minus 3y. The variables must have the same coefficient, 3, but opposite signs. Or you can say the variables must have coefficients with meaning negative coefficients. Like if it's plus 3, the other one should be minus 3. One coefficient should be the negative of the other. It can be put in any ways. So when you have two equations with two variables x and y, and if you have to solve for x and y using the elimination method, so as the method suggests, you will have to get rid of one of the variables. And that is possible only if the variables have, so like x or y, they have the same coefficients, but opposite sign. Only then it will become 0. But when you look at these two equations, the coefficient of x is 5, but here the coefficient of x is 2. Here the coefficient of y is minus 2, here it is plus 3. They're not the same. So you have one additional step here. You have to equate the coefficients of one of the variables. You'll have to bring them, you'll have to make them the same. So you decide which variable you want to eliminate. So here in this working, I have eliminated the variable x. In this working, I have eliminated the variable x. So how can I eliminate the variable x? The coefficient of x here is 5. Here it is 2. What's the LCM of 5 and 2? 10. So I make this 5x 10x. I make this 2x 10x. See, I want to eliminate x. So what is it here? 5x, here it is 2x. I want to eliminate x. 5x, 2x. What's the LCM of 5 and 2? 10. So make this 5x 10x, make this 2x 10x. So this is the first equation. This is the first equation. You can see here, this is the first equation. This 5x should become 10x. How? You should multiply the equation throughout with 2. Now this is the second equation. You want this 2x to become 10x. How will that happen? You'll have to multiply the equation throughout with 5. So this is called writing equivalent equations. Writing equivalent equations, like we write equivalent fractions. Like equivalent fractions, we write equivalent equations by multiplying the equation throughout by any non-zero value. You cannot multiply an equation with 0. Multiply the equation with any non-zero value. If needed, you can multiply with √2, minus √3, anything to get an equivalent equation. You should not multiply with 0. You can multiply with fractions. You can multiply with -3/4, anything accordingly, not 0. 5x, 2x. LCM of 5x. This is the first equation. This is the second equation. So you have decided to eliminate x. So you look at the x terms, 5x, 2x. The LCM of 5 and 2 is 10. So you want 5x to become 10x. You want 2x to become 10x. And how is that possible? By writing equivalent equations. So multiply the equations by a suitable number. So multiply this one with 2, this one with 5. The first equation with 2 and second equation with 5. So what happens? 5x into 2, 10x. Minus 2y into 2, minus 4y. 2 into 2, 4. Throughout you should multiply. Next equation, 2x into 5, 10x. 3y into 5, meaning plus 3y into 5, plus 15y. 16 into 5, 80. So we've written the equivalent of both the equations. Now you see we have 10x, 10x. Yeah, the coefficients are the same. But we have another challenge. 10x and 10x is 20x. It's not 0. Plus 10x is plus 20x. It's not 0. So we have to change the signs throughout. Changing the signs throughout is not a compulsory step. It's situational. If needed, you have to do it. Here it is needed because 10 plus 10x is plus 20x. You cannot simply cancel like this. So we change the signs throughout. Plus 10x as minus 10x, plus 15y as minus 15y, plus 80 as minus 80. Now 10x minus 10x is 0. So eliminated. Minus 15y, minus 4y, minus 19y. 4 minus 80, minus 76. Minus gets cancelled on both the sides. Y is equal to 76 by 19. Y is equal to 4. Y is equal to 4. Now, as we did in the earlier answer, substitute y is equal to 4 in any one of the two equations. See, we can see 4 here. These are the primary two equations. And these are the two equivalent equations. You can substitute on any equation. You will get the same value for x. You can substitute in the primary equations 1 and 2 or in their equivalents here. You will get the same result. So substitute y is equal to 4 in equation 1. I have put it in this equation 1. Y is equal to 4. Y is equal to 4. So we get 5x is equal to 10. X is equal to 10 by 5, which is 2. So in question number 12, subdivision 1 and 2, you have learned how to solve two linear equations in x and y by the elimination method. You have learned how to solve two linear equations in x and y using the elimination method. So here in the question, you're given two equations. Question itself, you have two equations. So we get correspondingly two equations. We solve and find the values of x and y. So I have to show you this one also. which we already discussed. Yeah, so see, if the question is like this, we have only one equation here. Here we got a quadratic equation. We split the middle term and we found the two values of the variable y. So I always emphasize on, trapping the question in your mind, having a picture of the question in your mind. How does a question look like? See here, solve the following equation for x. There's only one equation given to you. And mostly when the power is 2x and all, no, you will get a quadratic equation. See, 2x. You will get a quadratic equation. Quadratic, split the middle term and find the values. This one also, we got a quadratic equation. See, we have 2x here. So we got y square. So one equation, quadratic, split the middle term, find the values of x and y. Sorry, find the two values of y and hence find the values of x. In this question, in 12, yeah, here we have two equations. So we get two equations in x and y. We write x and y on one side, constant on the other side. So this is solving a pair of linear equations in x and y by the elimination method to find the values of x and y. Any questions, children?
No, ma'am. Ma'am, no.
Okay, all right. So Harsha and Lakshana was there. Maybe she had some network issue or maybe she had to leave. Not sure. Okay, thank you, Rahul and Harsha, for staying back till the end of the meeting. I hope the session today was useful.
Thank you, ma'am.
Okay, thank you. Thank you, Harsha. Thank you, Rahul.